Yeah, Safanis, can you hear me?
Yeah, Jeff, it was not like before how you are teaching us because today you are breaking up a little bit more.
Yeah, today breaking up means the voice you're talking about.
I mean connection. It's not like before. It's a bit difficult today to hear you because you are breaking up a lot.
Yeah, the voice you're talking about. Now, is it clear?
Yes, Chief. It's
Yeah,
clear.
now it is better.
Yeah, maybe because it was raining, because of that, internet connectivity was poor. But this that is the reason it got interrupted just now. What had happened because that interruption was because of the internet. So now, if you find any difficulties, yeah, you text me so that I know. In the chat, you can text me. Now, can you see the screen? What you are where we were in the screen? That Rockaram diagram.
Yes.
Okay,
Yes.
let us start then. So, have you understood that why it is kept like this, designed to minimize the side thrust, so that when it is fully open, side thrust is minimum, and just before that, it is kept the minimum side thrust, that is zero. And here also it is zero when it is completely closed. If we design such a this way, we can achieve the minimum side thrust so that the wear down of the bush is minimized. And in addition to that, we have these certain things, that is, we have the universal bearing here, as well as if you see it is a curve, it means it will be 1 point curve. But this contact point will shift. It will not be always on the center line. But if you have the universal joint, it will be contact point will be on the center line. But there will be, because finally the rocker arm is pushing it. So that that will travel in this way. That you cannot avoid it. In that case, there will be some side thrust, but it will be reduced. Whereas this is the design is made so that it can be reduced to minimum when it is opening the wall, the side thrust is minimum. Now another thing is this one. This one is X and Y. This is a lever. So this is the distance from the pivot point, which is the push rod, and this is the wall stem. Now this ratio is important to us. Why it is so important to us? Because your cam will be pushing this up. Because due to the cam, it is lifting and lowering. Now, how much lift is the cam having? It will be very small lift. And with that lift, we need to have the complete opening and closing of the valve, which is larger lift than the cam. Otherwise, cam size will be big, which we don't want. So this ratio will decide that how much will be the ratio between this X and Y, so that completely small lift of uh, cam will completely open and close the valve. It means the lift of the valve stem will be sufficient. So this design is made such a way so that Y is to X is 1.4 to 1.5. We keep it. So once it is kept 1.5 or to 1.4, so that is enough so that the column that can uh, the cam lift is small lift can cause the higher opening is the lift of the valve. And what is the this is around, it means the if you see this the cam lobe lift is smaller and the valve lobe lift will be 40 to 50% it will be. So this much will increase. So now tell me, anybody has any question about it, about this design aspect? If okay, if it is clear, then let us go to the next slide. Next slide is now excessive clearance. What will happen? Late opening and the closing early, because it has to, rocker arm has to touch to the valve stem, then only it will start opening. But your cam is trying to lift, but it is not, the valve will not open because of the excessive clearance, late opening and the early closing, and reduced valve lift, because valve lift is when it is start opening and closing, that is the, means they, if it is opening in from closed position to the fully open position, that is the lift. So it is late opening and the early closing, so the lift will reduce. And when, where and why it will be noisy operation, because every time, because of the clearance, it will hit the wall stem, so it will produce noise and it will damage the cam follower. Why? It is because of the shock loading. Because suddenly it will hit the, means it will touch the valve stem and the load will be suddenly very high, and in between, when it is passing through that clearance, excessive clearance, there will not be any load on the cam, so it will cause a shock loading. And what is this? This is the insufficient clearance. Then what will happen? The valve will expand, so there will be a clearance because valve will not close properly. And since valve will not close properly when the cam is, I mean, the follower is on the cam base circle, then what will happen? That during the combustion, we have seen if the valve is leaking, so exhaust will, that is the flames and the combustion product will pass through the valve and it will get deteriorated, it will become weaker and it will make a, it will burn away. That is the, and so eventually the compression will be lost because the power will be lost, and the power developed will be less, as well as valve will get damaged and valve will fail. So that is the consequences of excessive tapered clearance and the insufficient tapered clearance. So this part was remaining. Now this rotocap is already been done. This part we have covered already. Now we go to the this part. So now all of you have done this one. Uh, this one where you want to put a solenoid valve to have a control end valve, end we want to control, closing we want to control, that is the opening, it will be fixed for first exercise. If you put a solenoid here, then what will happen? When the valve is opening, that time we can release this pressure at any point. So we can control the end of the valve. That is beginning only same, because it will be closed when it is opening the valve. Now the uh, next one, how it controls the beginning and end both. This, if you see this diagram, this is the like if it is a conventional engine, this is the pump of the hydraulically operated valve. Now this one is the pump, the piston. Just think it is a pump piston, and how it is operated in conventional engine by the cam. We have the follower and the guide and the cam is rotating. So accordingly, there will be a lift. When it is moving upward, the valve is opening. When it is moving downward, valve is closing. Now in this case, what is happening? This is the 200 bar hydraulic pressure. This hydraulic oil means it is a system oil in the engine. And then it is coming here, it's going to this passage. And then there is a shuttle. This is solenoid operated shuttle. So this, in this diagram, this shuttle valve, you see how many ports? One, two, three. Three ports are there. Now this is the oil pressure. It's coming here in this position of the valve. This, suppose this is one, this is two, this is three. One and two is coming. So once this pressure is coming to the two, it is lifting the your servo piston, which is causing, after that it is connected exactly the same way like the conventional engine is. This is the pump, this is the high pressure pipe, and then it is connected to the actuator, hydraulic actuator, which is on top of the exhaust. So in this case, what will happen? This is solenoid control. The engine control system is giving a supply, and accordingly this position changes. At this position, what will happen? It is opening the valve, and after that, this solenoid valve, when it is de-energized, then what will happen? This the shuttle valve will change the position. Which way it will move? It will move the downward direction. Once it is moving downward direction, what will happen? One, there is a small piston. Can you see that shuttle valve spool? It will move down. It will come to this position. Once it comes to this position, then what will happen? The pressure supply. Now it's not connected. 1 and 2 will not be connected. It means once 1 and 2 is not connected, then what will happen? This piston will move this position. Now this pressure line is not connected. 1, this is 1, this is 2, and this is 3. So initially it was 1 and 2 was connected, valve was opening, exhaust valve. Now 1 is closed, 2 and 3 will be connected because this position will come here. So what will happen now? This will get drained to 2 will get drained through 3. So the piston, so the servo piston will move down. And once the servo piston is moving down, exhaust valve is closing. Now this we can achieve uh, at any beginning also we can control, end also we can control. And this engine control system, it has to get the exact location, the exact angle of the crank, so that uh, it knows when to open, when to close. Accordingly, there is an encoder on the crankshaft end, and then that is actually sensing the crank angle and giving it to the engine control system, and accordingly engine control system is controlling this. It means there will be uh, the central unit, control unit, and there will be individual uh, cylinder also will be controlled by a control unit, but these two will be connected. It means the engine control unit directly will not be controlling to all the unit. So individual unit will have a control system, electronic control system. So that signal comes here, and then accordingly it operate this solenoid valve to control the beginning and end of the exhaust valve opening and closing. And this is what you have seen. This actually it in details there is one other chapter which it will be taught to you. This is the accumulator. That means there will be an accumulator, so that sufficient oil is always there, so that you can this when it is moving up, that certain quantity is required, and so it is always it is been reserved. So there is no shortage of supply. Otherwise, this will not move the amount it should move. And this line, what you see, this is from the rail, and then it is going to the all unit. That's why it is showing. Is it clear that the variable beginning and variable end, and the previous one we have achieved the variable end? These two exercise, is it clear, all of you? Any questions? Any questions? Can you hear me?
Yes, Chief, we hear you.
Okay. Any questions?
Yes, Chief, I can hear you.
Yeah, tell me if any questions or you have understood. Yeah, David, tell me.
Yes, Chief. Can you please explain one more time how the during closing of the valve, how the
Yeah. Okay. So this valve has got 3 ports. 1, 2, this is 2, and this is 3. Now, if you see this 3 port, that is, this is 1, this is 2, and this is 3. Now, in this position, this throttle valve position is this at this moment. What will happen? This is the high pressure oil is coming from the rail, 200 bar it is kept, and then it is coming this way, and now 2 and 1 and 2 is connected. It will come like this, it is coming like this, and it is coming to the 2. So 2 is connected to the underside of the servo piston. This is the servo piston. And once this pressure is coming to this underside of the servo piston will move upward direction, exactly like the cam is moving upward direction, the pump piston, and then valve is opening. In this condition, the valve will open. So this is connected to the exhaust valve actuator. This is the actuator, the piston, which is uh, pushing the valve stem downward direction, and then it is valve is open. Now what will happen? Once this is de-energized, then what will happen? This piston, what you see here, this will move down to support this position. Once it has moved down to this position, what is happening? 1 and 2 now disconnected. But there is a pressure here that has to get drained out. Unless it gets drained out, this pressure will not be released from here. This will not close. So in that case, what will happen? The bottom part of the valve, it is also moving with the top part. Complete valve will be moving down. So what will happen? This will take a new position here. So this is the now. If you see the blue color line, what I have drawn, that will be the position line. In this position, what will happen? 1 is blocked. 2 and 3 now connected, because 3 is above the this lower portion, that is the it is the spool. So it is not blocking now. What will happen? 2 and 3 is connected. 3 is the drain, which is going back to the system. So now this pressure, this P is released to 3. It will come to the 2 and then 3 and will come to the drain. Now piston, servo piston will move down. Now once the servo piston is moved down, volume will increase, that has to be displaced. So the piston here will move up, and that will cause the closing of the valve. Now since this is a solenoid control, it means you can, with the engine control system, can change the at what angle it will open and at what angle it will close. So engine control unit, that is the engine control system, it is getting a crank angle. The crank angle sensor is giving the exact sensor with the location of the crank angle, and accordingly it can energize and de-energize. Once it is energized, the opening is starting, so it can change the angle, because it can send the signal at a particular uh, angle to open, and it can vary because it is electrical signal is coming in. And closing also, it can close at any angle. It can close. Suppose you intends to close early, it will send the signal at early. That means the, suppose the closing is 40 degree after BDC. Now it wants to close at 35 degree after BDC. At 35 degree after BDC, electrical signal it will send the engine control unit, and it will close. And it wants to open, instead of, suppose the uh, 40 degree before BDC, it wants to open at 32 degree before BDC, or 38 degree before BDC. Then it will send the signal at that angle and it will open. So opening and closing both is variable in this. Is it clear, Devut? Because this
Yes,
one,
Chief, it's
yeah.
clear. Thank you, Chief.
Okay. So now this chapter, let us see certain things. There was a question earlier from one of you, I think Ilma or Edmasu. So that is the intelligent engine, how the exhaust valve operates. This is the way exhaust valve is operating in intelligent engine. So this is the servo rail. So this is servo. This is one of the engine maker they do use. So this is the servo rail, which is 200 watt. It is lube oil is maintained, pressure, and then there is a rail valve and a slide rod, and this is a piston. This is the piston, like the previous diagram what we have seen. That is the piston, servo piston. When this piston moves up, exactly like the conventional engine, the pump piston moves up, then what happens? This is connected to the top of the valve stem, exhaust valve stem, where you have a hydraulic piston which moves down and the valve opens. And then when this piston, servo piston is moving down, this the air spring will push it up and then it will close. Now here what is happening? So rail valve first the signal from the engine control unit comes to rail valve. You can see this. These are the solenoid coil both sides, and how it is connected. This is the pressure line is connected here and connected here, and this is the drain line. In this case, this is the pressure line is blocked here, and the underside of the piston, servo piston, is drained. If you see the connection, it is drained. And in this case, what will happen? The Let us see what is happening when the engine control unit gives the signal. So once the engine control unit gives the signal, then this solenoid valve will get energized. Once solenoid valve is energized, then what will happen? It will change the position on the valve position. Once the position is changed, then what will happen? This pressure line, now it is connected. This is the pilot pressure which is operating the slide valve. So it is coming here and it is actuating this valve. That is the slide rod, it is called. And then once it is actuating here, then what will happen? So this will change the position. So if you see the initial first one, this was pressure line was blocked. Now this is energized. Pressure line will connect to the outlet, and then it is the pilot oil. It is the coming and actuating this slide rod. Once it is actuated, what will happen? This the pressure line, this position will move down, and the pressure line will be connected to the underside of the servo piston. You can see here. So it will come and connect the underside of the servo piston. Once it is connected to the underside of the servo piston, what will happen? This piston will move up, and this volume will reduce. Exactly the same volume has to be displaced. Where it will get displaced? It will be displaced on here in this side. So the valve will open against the air spring force. So this is the way. This is now displacing. It is coming on top of the hydraulic piston of the actuator of the exhaust valve. Then what is happening? It is opening. After that, what is happening? This is de-energized, this is energized. Once this is energized, then what will happen? The servo oil, now it is blocked here, and this pilot oil pressure is getting released to this. Once it is released, this will come back to its original position. Once it comes back to the original position, then what will happen? This position will shift, and then this line which was connected to the pressure line before, now this under piston, that is the below the servo piston, the underside of the servo piston will get drained out through this. Once it gets drained out, what will happen? The piston will move down, and now the volume is increased. This oil will come displaced and come to this side and occupy this volume, and the valve will close. So, is it clear, everybody? It is very simple mechanism. Any question, any doubt on it? And we have the valve position sensor. We can see here these two are the sensor. So how much is the lift that every opening and closing it is measured by this, and then it is sent to the control system, engine control system. If suppose the lift is more, it will correct next opening, lift will be adjusted. So it can be precisely controlled. Any question on this? All of you? Yes, softness. Tell me.
Yes, Chief, thank you. So if we are operating the rail valve every time we want to open and close, why we need the slide rod? I mean, why don't we just connect to the rail valve and minimize the cost?
So this pilot operated valve always we do use, because rail valve it is always operated by the solenoid valve. But it is a screening. It means it will not open the valve, but it will open this. So if anything goes wrong, it means it can be, suppose we want to something is wrong and it has to be stopped engine. So this become fail safe. It means there are two valves is in series has to work, then only it will open. So that is the reason always that if you see the any control system, pneumatic or the hydraulic system, there is many valves incorporated which is operated not directly. It is operated by the your pilot. It is pilot operated. Because of that, because it is the safety checks it's provided. And during the actually pneumatic control system, it is there in your syllabus in the general. I'll go in details that what is the effect and why we use exactly, why we, what all things we do avoid and we use the pilot operated valve. So it will not directly open this operate this servo piston, it will operate this and then this will operate. So it is like a checks.
Okay.
So any other question? The operation, all of you understood or not? Yeah, Melissa.
Thank you, Chief. On the top of this, the actuator, I see some non-return valve on the supply line.
Yeah.
And an orifice.
Yeah.
So what is the purpose of this non-return valve? There's
Non-return
some
valve
oil
is
coming, some other oil to this actuator.
This is the makeup.
Thank you.
Makeup oil. So if there is any leakage, it has to be makeup. And this is continuously part of the oil is moving out from the system, because we want to make sure that there is no air in the system. And it will compensate from here. So in conventional design, we have seen on top of the actuator, there is a vent, which is continuously moving some small amount of oil. Do you remember that? You can connect to that. And this supply was there in the pump, but here it is at this point. So that it is like the bleeding of oil. air if gets accumulated, it will continuously, it will go to the, it will move out from the system. Is it clear, Melissa? Melissa? Okay. So, I think Melissa has gone off here. But any other questions? So, any other question? If no question, then
Yes, Chief.
yeah, tell me. So, any other questions? Melissa, is it clear what I said? Have you understood? Melissa?
Yes, Chief. Understood.
Okay. Then what we do, we close this chapter here, and I'll send. Okay, let us start the next chapter. And so in this chapter, it is the camshaft drive. Now, what is the cam and the cam follower mechanism? Where we do use? It means it is the basic cam lock terminology. It means what is that actually? With the cam, we operate certain function of the engine component. For an example, the fuel pump, it is operated by the cam, and timing also is maintained, as well as the exhaust valve opening, closing, as well as the, it means the cam is a very important component of the engine for the conventional engine. And there are other use of cam also. Before we go into those, let us see the certain the terminology of a cam. This cam, in this diagram, we have two diagram. One is negative cam. One is so there are two cams. One is negative, one is positive cam. This is the negative and this is the positive. Because here you can see this is the negative. That means it moves down and up here, and this is, it's on the base circle, and then it moves upward and downward here. So now this terminology, let us see the base circle. What is the base circle? Base circle is the smallest circle which can be drawn on the cam profile, tangential to the cam profile, and keeping the center line at the cam center line. So what is that? Let us see this diagram. So this is the, if you see this, this is the base circle. So base circle, so the base circle, so so this is the base circle, which is the smallest circle you can draw. If you see this base circle line, this end here, this is the smallest circle we can draw, keeping the cam center. Cam center is this one. Keeping the at the cam center, if you can draw a smallest circle in the cam profile, that should be the tangent to the cam profile. What does it means? You can draw many circle keeping at the cam center as a center, but it has to be on the same line of the your cam profile, because this line is on the cam, and it can be more than that diameter, it can be less than that diameter, this base circle, but it has to be tangent to the cam profile. It means it has to coincide with this line. So what does it means? It will be tangent. If you draw tangent to this portion of the uh, cam, then those point, it will, this circle will pass through that point. That is the reason it is called tangent to the cam profile. That is the base circle. Now there is another terminology, that is the trace point. What is the trace point? And another thing, this the base circle will decide the size of the cam. We'll see how it is related to, because if your base circle is larger, it means the left is same, your cam size also will be larger. If base circle is smaller, your cam size also will be smaller. When we draw the cam profile, then we'll come to know that how it's exactly affected. If your base circle diameter is large, it means your cam also will be large, because base circle you are drawing onto the yes, uh, cam profile line, that is the tangent to the cam profile. So it will be, because of that, the cam size will be increased. Now trace point, what is that? Trace point is the on the follower. So follower is moving onto the cam profile, and that points each position of the follower. There will be points like this is the guide, and this is the follower. Follower is rotating. It has got a center point. When the cam is rotating, this follower, suppose cam is rotating in clockwise direction, the follower will press on the anti-clockwise direction. So this center line, these are the your trace point. Each position, the center line is called trace. So it will move around the cam profile. So for an example, this center line at this point, cam follower is at this point, and at the center point, that is the trace. So it will be all around the cam profile. So in fact, the follower, if you see this circle, the radius of this circle, if you add any point to the cam profile, that will be a trace point. So this is called trace point. And the pitch curve, what is the pitch curve? Once, suppose we don't rotate the cam, we rotate we move the follower on the opposite direction. Then what will happen? It means we instead of cam is rotating, follower, suppose cam was rotating in clockwise direction, follower was moving in this, it was fixed. So what has happened? So this point, this moment, this point was here, next moment this point will be here because it is rotating in clockwise direction. If we don't rotate the cam and move this follower on this line, on the surface of the cam, then what will happen? So there will be a curve created, and that is called what? The pitch curve. It means that curve, it will make a curve and generate a curve keeping the locus on the trace point, and it is called pitch curve. It means the center point of the follower that will move around the trace around this, and that is called pitch. We can draw a curve on that, and it is called pitch. Now the next one is pressure angle, which is another important thing for the cam. What is pressure angle? It means the angle between the direction of the follower movement and the normal to the pitch curve. What is this? And that angle is called the pressure angle. So let us see this. It means, and your actually the pitch angle will change when the cam is rotating. It's not fixed. It will be maximum at one point. It will be minimum at one point, and there will be a variation of the pressure angle, and this pressure angle will give you a side thrust because of the angle is high, there will be a side thrust produced. And how does it affect here? What will happen if the angle is more? We'll see this angle. What is it? That is the pressure angle. A pressure angle, if you see this is the center line of the center point of your cam, and this is the follower. The follower has got a center line, trace point, that if you draw a line, and in this point, if you have the curve, this is the your pitch curve. On the pitch curve, if you draw a normal at that point, and that line will have an angle with the follower motion. It means if you see this follower is moving up and down. That is a vertical motion it is having. And at any point, there will be a trace point. At that trace point, that is the trace point is, if you join all the trace point, it is the pitch curve. And if you draw a tangent to that, and then if you draw that point, and if you draw a perpendicular, that is a normal to that, and that line will not be on this line, and there will be an angle, and that angle is called pressure angle, and it will keep on varying as the cam is rotating. It will not be constant throughout the cam, and there will be a minimum and maximum pressure angle. The problem is that because of that pressure angle, there will be two forces. One is vertical force, one is horizontal force. And vertical force we are interested for because we want to lift the follower. But it will produce also a horizontal force that is called side thrust. So because of that, what will happen? There will be a side thrust. That's why you see the follower and guide. Guide take the side thrust. So now how to avoid that? It means we need to keep the pressure angle during the operation minimum. It should be designed such a way so that we can have the minimum pressure angle. Now, this minimum pressure angle, to achieve that, one way we can give the offset. Now, in this diagram, if you see, it is inline. This is the central line, center point of your cam, and this is the follower. Both, if you draw a line, and it will be a vertical line. This is the follower motion direction, and this is the center line of the follower. Both center point is coinciding, but we can give slight offset. It's not necessary it will be on the same center line. If we give some offset as per the design, we can calculate uh, and we can give slight offset so that the side thrust can be reduced. So that the pressure angle we keep around means there is a fixed thumb rule, but it can vary from design to design that what will be the minimum maximum pressure angle. This is the translational motion, and there is a this is the motion usually would be used. In that case, both the cases will be having a limit to the pressure angle accordingly as per the design. Before we go into that, how much it is. So let us see a certain remaining the definition. So this is the so pressure angle gives the side thrust. That is the reason. If it is the side thrust is high, what will happen? It will get jammed. The follower will get jammed. So it will not move up and down. That is the reason we keep that within the limit. What is the limit? If you see the pressure angle less than 45, low speed cam mechanism, that is the oscillating type. Oscillating type is a different type of cam follower motion. Let us see what is the oscillation type. This is the, so for an example,